Welcome to this video on creating piecewise functions in Desmos. So in essence, piecewise functions means that you're going to have different functions on the same graph, and each function will connect with each other, and they will each be defined by a certain domain. And we use domain and range here to really help us connect them in a way that is meaningful. And I feel like this is a good video to start with before actually making a roller coaster. So let's start off with a simple parabola, y equals x squared. Okay, so firstly, I think that I want my whole piecewise function situation to exist when when x is greater than 0. So I want to cut off everything after here. And so let's do that. So let's have x is always going to be greater than 0. Okay, so get rid of that other part. And now I want to stop this function actually over here at x equals to 2, or y equals to 4. Um, let's do the y. Let's just state it by the range just to have some variety here. So y I want to be less than 4. Okay, so we're stopping at 4. Awesome. Okay. Now I think I'm going to want to have a horizontal line going from 2 until 6. So I'm going to have y equals to 4. So that's the line. That's the line that's going to go along here. And I want to declare that its domain will be as such. So I want that y should be greater than 2, but less than 6. Actually, no, I want to say the domain. So x has to be greater than 2 and less than 6. And there we go. We got our line. Again, this kind of stuff requires a lot of playing around, but you'll get it with practice. Okay, let's get fancy here and let's add a sine function. So let's first just write it out. So y equals to sine of x. And now I want this function to move up and sort of continue off from this point over here. So let's add 4 to it to bring it up. Okay, so generically, sine oscillates around the x-axis or the y equals 0 line, and now we've moved it up, and now it's going to oscillate around the y equals to 4 horizontal line. Let's zoom in here a bit. Okay, so I want it to continue here. So we are going to have to move this function to the left. So if you remember about how to move functions horizontally, so this is where we're actually wanting a horizontal shift to the left. So we're gonna have to add a number inside the bracket with the x. So let's just try adding 1 and see what it looks like. So we added 1. Let's take it away. Okay, so we can see that when we add 1, it moves a bit too much to the left. So let's try adding 0.5. Okay, we're getting a little bit better. Let's decrease that 0.5 a little bit. Let's make it 0.4. Okay, even closer. How about 0.3? Okay, I think we're getting really close here. Pretty close. Okay, we can sort of leave it at that. I mean, we can make it like 0.31. Okay, now how about 0.29? I think this is okay. Let's just leave it at 0.3. Okay. Now, I want to cut off everything from 6 onwards. Okay, so from 6 and before 6, I want everything up to 6. I want to crop out of this graph here because I don't want this stuff to exist. I want it to continue like this. So let's set a domain here. Okay, so we're going to say that this graph should exist as long as x is greater than 6. And there we go. We can sort of see it visually. Of course, if we zoom in, it's not perfect, but it's okay for right now for this demonstration. Okay. I also want to stop this graph now at x equals to 9. So let's introduce that. So let's do it that way. So we have our graph simply as a little like hoop, okay, a little hill. Okay, so if this was your roller coaster, of course shouldn't be a roller coaster because this would be unsafe, but it would go up and then down, and now I want it to continue down linearly all the way to the bottom. So we need to create a linear equation here. So this linear equation that we're creating, there's many ways to create this, but I think that the easiest way to start off with is just to look at what the y-axis would be a bit, and also to determine that the slope here will be negative slope. So I think that it will go kind of from the 11 as being the y-intercept. So let's start creating one right now. So y equals to 11, and then let's just do minus x because that would be the slope, okay? Or we can write it as negative x plus 11. Okay, so it's not perfect yet, but we're on our way, okay? Well, the slope is almost perfect. I mean, it's not exactly, but we'll move this line here. Let's move it horizontally a bit closer to where it has to match up. So let's, the same way as we did with the sine graph, we're gonna have to put brackets for the x's, and we're gonna have to apply horizontal shifting. So this time we're moving this whole graph to the right, so we're gonna have to do minus a certain amount. So let's try with -2. Okay, we're pretty close here. So let's try changing the slope, okay? Because I'm noticing that the slope is a bit too steep, so we're gonna have to move it. We're gonna have to make it less steep. So we're gonna add a multiplier in front of our x's, and right now the multiplier is 1. So if we want it less steep, we're gonna have to make it less than 1. So let's try 0.9. Okay, so this line kind of is looking almost very similar to this last portion of the slope here, but it moved a bit too much to the right. So we're gonna have to back it up. We're gonna have to make the horizontal shifting here, not by 2 anymore, but something less than 2. So let's try like 1.5 again. So you're just playing around with it. And as you can see here, it came a bit closer. Let's decrease it even more. 1.4. We're very close. Okay, let's zoom in a bit here. Let's see if we can fix this up a bit. Okay, it's not exactly touching, but so let's like try decreasing a little bit more. So 1.4, let's try 1.39. We're pretty close here. How about 1.38? Okay, great. We're touching the graph. We're even touching it. You see, we're touching it at 2 different points. So I think we're pretty good here, right? Because this thing will continue down here. I just want to clean this up. So it will continue down if we're looking at the larger picture here. And so I want to cut off this top portion, and then I want to crop out actually this last portion of the green that actually extends. So in order to do that here, I think it's pretty easy. We just have to pick our point here. So this is the point at which it first touches this line here. So I want to have x. I want to have the purple line exist from this x value until it touches the ground, okay? And I want to have this green, the sine function stop at this x. So I can stop the sine function first by just changing this 9. So I'm going to change that 9 to 8.639. So 8.639. We can see that the graph stopped exactly at that point, okay? Meets exactly there. And now let's cut off this original function. Let's say that x has to be, okay? X has to be greater than 8.69. Sorry, that was incorrect. X has to be greater than 8.639. There we go. So it continues exactly off from it. Perfect. And now I want this graph to stop when y is 0. Okay, so I don't really even need to think about this 3.06 or 13.602 and like put that into my domain over here, though I could, but I can actually add another bracket. This is very simple because what we want our graph to stop when it hits the ground, and that's when y is 0. So let's just state here that y has to be greater than 0, and we're done. So we can see how we use domain and range to identify different regions of the graph. Thanks for listening.